what is machine learning? Machine learning is really about building something that you can either see as a tunable program or a very flexible statistical model that is able to predict from data and to apply to unseen data. So the idea being that I'm going to use labeled samples, so data with labels, to learn a link between this data, these measurements, and those labels. So for instance, I might have two labels, two measurements that you can see here, and I might want to separate the light blue from the dark brown dots, in which case I need to learn that I need to draw a separating line between the two. So this is a fairly simple example. It's an example of a classification task. I'm trying to separate two classes. I might want to predict a continuous variable. If I'm trying to predict a continuous variable, then I call this a regression task. And it's, some elaborate form of curve fitting. In Scikit-Learn, all our data is represented as a NumPy array. So a NumPy array is a table of numbers. And here we are focusing on measurements that are represented with a 2D array. So an array that has n features, number of columns, and s samples, number of rows. So it means that we're going to have to describe all our data as rows with a given number of numerical features. And of course, this is part of the work, and I'll come back to this. So one way to illustrate this is to consider a historical example, which is that of classifying irises. Irises are flowers, and there are different kinds of irises. And the question that a researcher was historically interested in was, can we derive simple rules that allow us to distinguish between those types of irises? So I want to design an algorithm that will recognize iris species. And so I've got those irises, and I'm going to need to build a data matrix that I can feed in Scikit-Learn. And Scikit-Learn is stupid. It can only take a 2D array of size n samples times n features. So in such an example, what would n samples refer to? It would be the number of irises that I have. And what would n features refer to? Well, that's more of an open question. I need to go from this problem of irises to a set of measurements that I can feed in my algorithm. And so the historical way this was approached is by measuring the characteristics of the irises and measuring what's known as their sample. So the historical researcher went out in the field and measured the length of the sepal, which is here, and the petal, which is inside. And he built a table with different irises of different species, with each time the length and the width of their sepal and their petal. So what you can see is that he transformed the original problem, which is a problem of the flowers, into a problem of numerical measurements by using the width and the length of the petal and the sepal. Now, once we have this, we have 4 features: sepal, length and width, petal, length and width. And we have 3 types of irises that we need to predict, which are the kind of irises, and their names are Sentosa, versicolor, and virginica. I don't know how this translates to Spanish. So this data comes in with Scikit-Learn. It's a historical example. So we can load it with Scikit-Learn with the following lines in Python. And then we have this iris variable, and we can look at the corresponding data, and we can look at its shape. And so we print iris.data.shape, and the result is 150 times 4. So what's 150? 150 is the number of irises I have in my data set. So it's the number of samples. And 4 is the number of feature per iris. And here it's 4 because it's sepal and petal times length and width. Okay? So I can look at my first iris, and my first iris is described by 4 numerical features, which are those numbers. I can look at the associated target. So for each of those measurements, I have a target, which is the number of the class that I'm going to try to predict. So you can see here that in my data set, I have class 0 first, then class 1, then class 2. And so my problem is now going to go from this type of measurement to this type of measurement. So I can try to visualize this data. Now, I can visualize, for instance, the sepal width and the sepal length and use the color to denote the class. So I've done this here. So I'm looking at only 2 of the features because I can't do 4D data visualization. But even looking at 2 of the features, I can guess that I can find separations, for instance, with a line along here, okay? So by looking at this, I can start to understand the problem of machine learning, which is to find numerical rules on these data to learn to discriminate those classes.